Why is the speed of light such a strange number? This actually has something to do with the French Revolution. Taking a look at the definition of speed, the magnitude of the change of its position per unit of time, usually expressed in meters per second. So, to understand where this number for the speed of light comes from, we first need to understand how the meter and the second came about. Before the French Revolution, the definitions of measurement units in France were quite chaotic. For example, there were as many as 250 definitions for the standard foot, including the Paris foot, Toulouse foot, and Strasbourg foot. These old standards were full of randomness and feudal dependencies. For instance, the French foot was the length of a foot, and the French inch was the width of a thumb. Most importantly, the standards for weights and measures in a region were typically defined by the local feudal lord or bishop. They had the power to define the standard foot and the standard bushel. When peasants and merchants used these measurements for transactions or paying taxes, they had to use the lord's measuring tools and pay a fee for their use. This allowed the lords to profit significantly. Faced with this phenomenon, the revolutionaries were outraged. This was a symbol of feudal exploitation and power. France pursued liberty, equality, and fraternity, and all the old measurement standards represented decay and injustice. We must establish new standards. Let everyone use them equally. Thus, at the French National Assembly in 1790, the Assembly commissioned the French Academy of Sciences to conduct research on the standards for quantities such as length and mass. For the definition of the length standard, there were two proposals at the time, one based on the length of a seconds pendulum, and the other based on the length of a meridian arc. The French Academy of Sciences believed that the length of a seconds pendulum depended on gravitational acceleration, which would vary in different countries and regions, and therefore did not align with the principle that the new standard must be universally applicable to all humanity. Consequently, they adopted the second proposal, defining the meter as 1/10,000,000th of the distance from the Earth's equator to the North Pole along a meridian. Beginning in 1792, under the leadership of French astronomers Delambre and Méchain, the French Academy of Sciences spent 7 years completing the measurement and calculation work and produced the world's first standard prototype meter known as the Mètre des Archives. On the 1st of March 1875, the French government convened the Metric Convention Diplomatic Conference, and on the 20th of May 1875, the Metric Convention was signed, establishing the International Bureau of Weights and Measures, or BIPM. From then on, the meter became an internationally recognized unit of measurement. Under the promotion of the BIPM, the prototype meter was eventually recast in platinum iridium alloy. During the first General Conference on Weights and Measures, multiple meticulously measured copies of the prototype meter were distributed to countries that requested them. However, it wasn't long before issues arose. As matter, it inevitably experiences atomic motion, with some atoms escaping over time, causing the prototype meter to gradually shrink. This made it difficult to meet the demands of many fields in physics and engineering. Considering that controlling temperature to absolute zero to minimize atomic motion posed significant challenges, there was an urgent need for a completely new measurement standard. This new standard had to be constant, precise, and unchanging regardless of how it was measured. What could meet such a requirement? In 1905, Einstein proposed the groundbreaking hypothesis of the constancy of the speed of light in his paper on special relativity, suggesting that the speed of light in a vacuum is a constant. Throughout the 20th century, numerous high-precision experiments were designed, all of which verified the principle of the constancy of the speed of light. We all know that distance equals speed multiplied by time, and since the speed of light is a constant, the distance traveled by light in 1 second becomes a perfect reference for length. The question then becomes, can we accurately measure 1 second? As it turns out, time happens to be the physical quantity that humans can currently measure with the highest precision. Scientists discovered that when cesium-133 atoms transition between the two hyperfine energy levels of their ground state, they absorb or emit electromagnetic waves of a specific frequency. This frequency is extremely stable and immutable. Thus, 1 second was defined as the time it takes for 9,192,631,770 oscillations of this frequency. As for why this particular number was chosen, it's rooted in historical reasons. This number was selected because the resulting second aligns most closely closely with the classical definition of a second based on a 24-hour day, with each hour divided into 60 minutes and each minute into 60 seconds. Adopting this definition meant there was no need for clockmakers worldwide to recalibrate their clocks. In any case, thanks to the stability of cesium-133 atomic oscillations, humanity can now measure a second with precision up to the order of 10 to the minus 16, which is sufficient for any scientific research or engineering application. With the speed of light as a constant and the second as an ultra-high precision unit of time, it made perfect sense to define the meter as a fraction of the distance light travels in a vacuum in 1 second. As for the specific fraction to use, it was simple. The result needed to be sufficiently close to the old definition of the meter. After all, if the difference were too large, many existing engineering designs would require adjustments. It was eventually discovered that when the denominator was set to 299,792,458, the resulting length of the meter matched the old meter almost perfectly. Thus, the definition of the meter was born. Conversely, this means the speed of light is 299,792,458 meters per second. Therefore, the value of the speed of light is an inevitable outcome of how we define the meter, and all of this traces back to the French Revolution, which seemingly had little to do with physics at first glance. So, this seemingly coincidental number is no coincidence at all. Instead, it is a deliberate choice made by humanity in the pursuit of precision, universality, and convenience, the ultimate product of the collision between human history and scientific inquiry.